Welcome back, gentlemen. Today we have dirt bike block, tranny case. I don't really actually know what you call this. Is it just a short block? I don't know. Anyhow, it's probably hard to tell in the video or on the camera, but these cases are actually different. Something must have happened to one of these and it blew apart, and somebody picked up a new half or aftermarket half of a case and put it together here. It's really obvious, like the casting on this middle section, whatever this is, seems to be quite a bit better than this outside case. There's a lot of pitting and a lot of, I don't know, looks like weird stuff in the casting itself in this other section. But anyhow, what we are doing is, what are we doing? Ah, yes, there is this ear here. We are going to, you see that's broke off. I'm going to be welding on a goober on there, flattening it out and drilling and tapping that. So we got a new bolt hole there. I got to measure those threads. It's metric, but I don't know if that's a 6 by 1.5. I got to measure. Well, try to measure what's left there. And here, there's a little inspection hole. Something or someone or whatever made that we gotta plug up. So we'll be plugging up that inspection hole. And then the last thing, I guess this was ran this way. You probably can't see this in the video either, but there's a big step from this one half of the case to the other half on both ends here. The intake part is smooth, well, as smooth as you can get, being two pieces. But yeah, the jug side here has got a, I don't even know what that is, 30 thousandths, 40 thousandths step. That's a pretty big step in there. He said it was ran that way, but he wants it flat. So after I get this welding done, work on that, we're going to be setting this up in a mill and skimming this off until this half of the case is flush with this other half. And I think we'll just do one last pass. Barely took off any material on this side because we don't want to cause piston interference with the top of the head. Just to make sure it's flat, and then all the way across to make sure this whole plane is flat and true and the jug isn't sitting crooked or whatever on here, so then everything rides straight. So yeah, let's get at it. Welding stuff. This case is already obviously cleaned, so we don't have to do a lot as far as cleaning wise goes. All right, we'll check thread pitch here. There's a 1.5 that does not fit in there. 1.25. Yeah, this is a 1.0, so it must be this. Yeah, that looks about right. And it looks crooked. We're gonna have to straighten that out too, I think. There's a little bit of junk in here. Let me clean this out. Doesn't need a lot of cleaning, just a little bit. Get some junk out of those threads. It's chlorinated anytime here, non-chlorinated. It's not a great idea to ever use brake cleaner, like in general, for cleaning parts before welding, but if you do, absolutely make sure it is non-chlorinated brake fluid, or else you will have trouble in the brain. And what I mean by that is high heat causes chlorine to turn into a gas. It's actually and it can turn into, I think it was phosgene gas, which is super bad for you. Cause all kinds of neurological problems and problems with your brain, and can kill you. So yeah, absolutely never ever chlorine used for cleaning before welding. Acetone is a good one to use. It evaporates quickly and doesn't leave nothing behind. If you do got to use brake cleaner, like I said, non-chlorinated, and give it a good long time to dry off. Even non-chlorinated, you still don't want to be turning any liquids into gas and breathing that junk in. My go-to rod for aluminum is usually 40-43, but for cast and stuff where I want a little bit stronger aluminum, a little bit, it can crack easy, but it's stronger overall. I'm using some 53-56 today. That's what I usually try to go to for cast parts, like repairing blocks, cylinder heads, yeah, anything you need the strength. Yeah, I am just going to go after this because there's nothing super crucial here. I believe this bolt is just for holding, must be the clutch cable or speedo cable or something in here. I don't think it doesn't hold a lot way off on the side here. So either way, yeah, we're just going to go after it. No preheating or anything after this one. This is red tungsten, 2% thoriated. And you see, I don't know if you can see it sharpened to a point. I used this for welding stainless just yesterday or something. So yeah, we're just going straight from that to aluminum here. Pretty typical cast. There's still junk in the metal. Even though it's been cleaned, you can see how black that is. There's a lot of contamination. Cast is porous and it brings junk to the surface when you melt it. Here again, especially engines. The cast soaks up a lot of oils and junk, especially when it goes through thermal cycles like an engine. It gets heated and cools, That cast really soaks up all those oils, and before welding you got to bake them out. You do this a couple of times with no filler. Bring all that junk to the surface and clean it with a brush or even grind it out. We'll see how bad this is, if I can get most of this out or not. That looks pretty good. After you get done filling it up this way, horizontal here, well, horizontal as it's sitting now, I'll flip it up on its side and then I'll fill this top out. Make that proud of this surface, so when we grind this down and make that smooth, I could do that in the mill because this is flat with the face for the jug here. I'll mill that off so it's parallel or in plane with all of this, and that'll be nice. Then we can drill it out and tap it. I did mess up already. That original hole that was there, I should have took a measurement off of that, how far that was between the edge of that hole, that threaded hole that was there, and this wall right here. Hoping it's not a super critical thing. Like I said, I believe it's just here to hold the tachometer or clutch cable or whatever in here on the end. And yeah, he's got some play and adjustment there. For something more critical, like any of these holes for the cases to go together or anything else, you definitely want to get some measurements off that hole before you go and start welding it up and doing things to it. Okay, there we go. That should be plenty. Make a new ear out of that. Since we were here and while the part is still warm, we're going to go to fill in this knocked out part, whatever happened there. So, alright, get that copper in there, just like that. There we go. That hole is plugged up. I did pile quite a bit of material in there. If there is something that's going to interfere inside of this case, you'll have no problem taking a grinder and clearancing it out, make sure it's all going to fit. I don't know if you guys can see what the hell I'm doing here. He said he doesn't care what it looks like as long as it works, but I mean, yeah, it's not 100% restoration on some super collector car or something, but just round it off a little bit on this outside. Yeah, I left this top, so like I said, when this is all assembled and in the mill, I'll just come across here and flatten that whole thing out. But yeah, I just wanted that nice rounded radius on the outside there. Make it look like something at least. And I just realized I ground all those metal shavings towards my open beer. How bad can it be? Good enough. Alright, not much to that. I'll meet you guys over at the mill. Alright, it's been a while since I used my mill. Give me a minute here while I clean up. Move this table over. Hoping I got enough room to set it up right here. I don't know, we're going to see. This is an unheated, well, I heat when I need, but typically this is an unheated shop in Wisconsin, so you get quite a bit of temperature swings. Causes a lot of condensation on metal parts and tools like the table and the lathe weighs, so I usually keep stuff pretty heavily oiled, even like you saw after I was done with doing whatever I was doing last. I still, even though I didn't clean it, I still shot everything down with oil. Mount down the block. This is going to be a good time. These are just homemade. I'll probably show you guys. Just a homemade machinist jack. It's, you can see the mill scale here. This was 1.5 inches round. I believe that's 1.5 inches. I just did a taper on the top, drilled a hole, tapped it, and just have a bolt in there. And the bolt, well, you guys see some rust there again, but the bolt head I just turned till it was flat. And these work good for machinist jacks. Nice, quick, and easy. I don't actually have a machinist level. I just use construction level for now. Someday I'll get a machinist level, but definitely high on this side, so we're going to let these jacks down some. Fairly level enough to get started. Yeah, that's pretty close. Let's figure out how we're going to tie this down. One thing people don't think about when they want something machined is how long it takes to set something up. The setup time is a huge deal. Quite a bit difference between these two halves. This one is showing being perfectly level, parallel, flat in the x-axis, and this one is not. It's actually showing like 4 thous high in this corner, but then going across front and back, I'm showing it's within 1 thou going back and forth. At least on this back side. On this front it dropped off, so this corner of this case half is high. Again, I don't know which one's the new one. I mean, I'm kind of assuming this is the new case half because it looks a lot better than this other one. But yeah, it's sitting 4 thou high, so we're dialed in as close as we're going to get here. We're within 1 thou on the Y, and well, we're within it looks like a 1/2 thou on the X on this case half, but 4 thou in the X on this case half. The way it's set up right now, this corner is high, so that is what it is. It's gonna get machined right there. Sorry I didn't notice you guys couldn't see. Alright, get this. There's where we're gonna start. So make sure it clears this side and make sure it is going to clear these nuts coming across here. It looks like it'll clear right there. We'll start with that. See what that's gonna look like. We don't want to go too fast. I think that's fast enough. Yeah, looking down, I can see that it should clear these nuts. Let me get closer here. Yeah. Yeah, it's gonna clear that nut, no problem. We're a bit above the surface, so I'm gonna start in the back here. And I'm going to run it up across here, and we're going to work on this weld and a little relief in the back end here. I'm just hand cranking this. I don't have a power feed on my Y. Just on the X-axis, and actually I broke off the power switch for turning on the power to the power feed. I'm actually going to drop that down a little bit. You don't need to take off that much right away. So now that weld is knocked down flat. Alright. We're actually hitting on the very edge of this outer case here. There's like 3 cases here put together. So I'm going to bring it up just till I start touching this. There, you can hear it starting to touch somewhere on the top of that case. We'll go across. It was just starting to nick it right here on the back side of this middle case part, whatever side this is. So yeah, we'll start doing probably like, I don't know what to start with here. Let's do 10 thousandths and see what it looks like. It's just starting to hit on the front of this case, and it should be hitting on the back of that case as well pretty soon here. Or case half, I should say. Oh yeah, we are almost right there already. So yeah, this 10 should be rubbing on the other case. Not even. Okay. Well, I'm going to back this all the way. Right there. I am just going to go up 4 thousandths. Because, yeah, it just started to rub on this half of the case cover right here, or this half of the case. So I'm hoping 4 thousandths. This might be our last pass actually already. I'm gonna see if I can get you guys down a better look for this. So yeah, what I was saying, let's just stop this. You can see right here, it just started to make contact when I was raising it up this last time on this case half. And I actually don't even feel a lip in between the case halves right now. So yeah, this might be our last pass. Like I said, in this case half, I'm just making complete contact. And this cover where we welded this ear on and stuff, that's complete contact there as well. That's nice and flat. So I raised it up. I raised the table up 4 thousandths after I made contact with this. So I'm assuming this entire surface, actually I should maybe drop that down and only do 3 thousandths. Take out as little as possible. I'll put it at 2 and then watch it and see if it's making contact all the way. So see if I can hold both things here at one time. Yeah, it's starting out full contact at 2 thousandths. Well, almost. The very edge of this ear. I don't even know if I should go up past that. I don't know if you can see it's making contact here already, but the very, very edge of this ear isn't. I'm going to go up 1 more thou. Just so it's making that full contact. There. Hopefully that 1 thousandth does it, so let's see. A little bit better. Yeah, that'll be good enough. That is almost completely full contact. I'll show you after we get done making this run. But yeah, this would hopefully be the last pass here. Crank this slow by hand. Get a nice finish for this guy in this final pass. It's looking really good so far. Sorry if the camera's moving around a lot. I'm trying to hold the camera on one hand and feed the machine with the other hand. Watch both at the same time. Right. Definitely got a pretty nice finish. A little bit. Yeah, it's a nice finish. You guys can pick that up in the camera. It's a little bit different finish on this case half than this other one. You can see where there was a couple of nicks here where it didn't take out, but I'm not going to go past that. Like I said, I don't want to take off more than I have to because that would cause interference piston with the head. So he said he ran it like this before, so I mean it's better than what it was. These nicks will be okay. This is just, I don't even know if anything goes in here. These are just ports for exhaust side or something. They're just pockets. So the main thing is it's got a good surface all the way around on the outside. This case half really machined nicely. You see like just a little bit right there too. It didn't catch, but that'll be okay. That's fine too. Because even though it didn't catch it, it's like right there. The gasket will make that up. Plus, there's enough bolt circle there to take it up. So, yeah, that looks perfect. Like I said, while it's in the mill, I'm gonna drill this out, set it up, drill, and tap it while it's in the mill, because this is a flat surface. It just gets drilled just like this. So we'll do that next here. This boring head is actually a Bridgeport name boring head. It's been around, but yeah, I don't know if you can see it right there. It says Bridgeport number 2. Bridgeport number 2. And I really like it. Like I said, you can see all the pitting and all. Taper's pretty rough. I should maybe look in. I don't know if that's one piece or not, if I can replace that. You run out of space in a hurry in a mill. Put a tall part in there. Especially you take a taller part, and if you gotta put this like in a rotary table or something, you run out of room in a hurry. And another thing I'm doing not technically correct here. Typically something like this, you would want to do a spot drill first, just to get that spot, or a punch mark first, mark it out and then punch it. Do a spot drill and then go to your normal jobber drill. But there we are all the way through. The tap is actually or the thread pitch is actually a 6mm 1/0 pitch. No, that is not the correct way to hold a tap. But it is okay. That looks a little fast, but let's send it. That wasn't bad. I think that was almost all the way through. Let me clean that up. Not quite. We'll go. That's all the way through. There we go. All right. It is done, completed. It ain't done until you try to bolt. Yep. There she is. There we go. Now it's complete. I may not always clean my mill when I'm done, but I always put my clamps and mill tools away when I am done. All right, there we go. One welded up machine case. I'll leave those few bolts in here to keep that together for them. But yeah, this is all smooth. Everything is lined up. Much nicer. Very good. Yeah, the finish came out really nice. for this jug, and yeah, this ear came out pretty nice. At least I think. I don't know. Yeah, do a little bit of filing on this edge here yet, just to break that edge. There we go. Doesn't need much just to break that edge. So you don't cut yourself. All welded up, fixed, hole patched up. It doesn't leak out of the case anymore. Ear welded on. You see that? Oh, there's a little pocket in there, but yeah, the ear welded on and drilled, tapped to 610. Yeah, job complete. This surface came out really nice. I'm happy with that. Yeah, all machined, all done. This job is done, and we'll send it on. So, thanks for watching. Again, all 3 of you, maybe 4 now. I was watching. I got another subscriber. Thank you much.